Good afternoon, good evening, everybody. Welcome to our Machinations webinar. It's great to have you here, or welcome back to another session. Today we've got our Unity webinar. Where we're going to be talking through the Unity plugin and showing how we can improve the workflows going between Game Engine and Machinations. We're going to show you how to integrate your Machinations model with your Unity project, show the workflows to help you find that perfect balance for your game, how to quickly change parameters in Machinations and test them in the engine, how you can change parameters in the engine, and then do some quick runs in Machinations. All about finding that perfect balance for your game. Before we get started, down the bottom of your screen, if you click the little chat icon and change the default option here from all panelists to all panelists and attendees, then if you could drop into the chat where you are in the world and which studio you're from, just so we know who we've got here today. And please do chat amongst yourselves as we go through today's session. My name is Matthew. I'm the evangelist for Machinations, and alongside me, as always, is Cesar, our diagram craftsman. We have a special guest with us today, Axon, who's going to be walking us through the API integration and how we can do everything between the Machinations platform and the game engine. Also lurking about in chat is Horia from our growth team, who's going to be keeping things flowing and answering any questions as they come up in chat. At the end of today's session, when we get to the end, we'll turn off the recording. We'll love to invite you up onto the panelists to talk to us about game design, talk about anything you've seen during today's presentation, or just talk about game design and Machinations in general. We've got plenty of time to answer any questions that you have, so please do drop any questions that you have into the chat as we go through, and we'll try and jump to them. It's really important. If there's something that's not clear to you, I'm sure it's not clear to other people, so please, if you're not sure about something, just drop it into the chat. And today we're going to be asking your opinion on how to balance our project as we go via polls, and I'm going to kick things off with our very first poll just to get an idea of how much you've been using Machinations so far. And while I launch the poll, I'm going to seamlessly transition from myself over to Axon, who's going to share his screen. So just drop into the poll there, how much you've used Machinations so far. Not used it at all, through to everything's in there and you're already an expert.
So, welcome everybody, and happy to have you here. Happy to be here.
The results of the poll. Sorry, Axon, cut you off before you get into it. So most of the people are doing some doodles. We've got people ranging from not using Machinations yet to doing their full meta. Brilliant. Sorry, Axon, over to you now.
Yeah.
What you've got.
I was too excited, man. I was too excited. So yeah, let me walk you through the little world of tanks we got going on here. This is an example that Unity have been using to demonstrate how to integrate scriptable objects many years ago, and we've hacked away at the example a little bit and improved it for the purpose of this webinar. This is also what we use to demonstrate how to integrate the Unity plugin with Machinations. So what you'll see different in this example is that there are these things spinning around on the screen, on the scene. These are buffs and debuffs that the enemy tanks have been dropping when they got destroyed. So now every time a tank is destroyed, they make the game harder for the player. And the player doesn't need to pick them up. I'm the blue tank over there, so I don't need to pick them up. They are just there for notification purposes so that we know what's been going on. And I can show you right now, for example, I can walk you through the buffs and the debuffs. Let me move the annoying zoom stuff. So this is increasing the enemy damage. This one is decreasing my speed. This one is, the barrel is increasing the weight of my shell so that my projectile doesn't fly so far. So as you can see, my projectile didn't fly very far. I'm a bit overpowered in this one, so I can insta-kill all enemies. And Cesar will show you how that looks on the diagram. And as you can see, the other tanks are chasing me, and now this buff drop that is decreasing my life. There is this buff that increases their speed, this one which decreases my cooldown, so then it increases my cooldown so I cannot shoot as fast. This one increases their life, this one decreases my own life. This one increases explosion force and radius for all the players, and this one increases their cooldown, increases their shooting frequency, so it decreases their cooldown, they become much more aggressive. All of the drop rates are stored in the scriptable object that you can see here on the right. This is synchronized to Machinations, and this is weight-based, so any value you have here, you can put whatever you want, like 800 or 900, and it will automatically calculate the percentage of that particular thing dropping. And also we have scriptable objects for the tanks and for the, look at him, just look at him shoot. He's crazy. So we have here the scriptable objects for the tanks. And for example, here in the enemy tank stats, you can see health and speed, and also the current buffs that they're getting for health and speed. So as the game progresses, these values here, the current buffs, will be changed based on what drops happen. For example, now you saw that little orb dropped there. So that means that my own tank shell will have an increased, you see this -40 there, it indicates that I have less speed for my projectiles. And now I'll let Cesar walk you through the beautiful diagram that he created for this game.
Let me also unmute myself. Yeah, so you saw Axon's game. Those of you that know our previous video with Unity integration know that we also used the same tank game in that video, only in a more rudimentary version. While Axon has made upgrades to the game in the form of debuffs and buffs, I've also updated the diagram accordingly. So the game's essentially a battle royale type of game. There are 6 tanks that are going to shoot each other until only one of them is left alive. And that's what we're going to be keeping track of here. Now, what I have on my model is my player tank, where we store the player's HP. And if I hit play right now, you're going to notice that we have player HP, and each individual enemy tank is stored in a pool here. You're going to see that once in a while, every tank shoots. If they do successfully hit an enemy, it can be any other enemy. So whenever a tank shoots, there's an equal chance to hitting everyone else, except for the player. The player has a bit of a higher chance because you'll notice when Axon is playing that he's playing quite aggressively, so the other tanks will usually gang up on him. That's why I gave the player a bit of a higher chance. Of course, this is adjustable according to player profiles and how everyone chooses to play the game. You can also see now, since this is a good opportunity, all of the 5 tanks have lost their HPs. That's because, as Axon mentioned at the beginning, the player is quite overpowered. And how do we make the player overpowered, or how do we make the enemies overpowered, is by using all of the red pools and connections that we have here. We can thus modify certain parameters for either the player or the bots. So we have player and AI health, projectile force for both of them, projectile radius, projectile speed, damage, tank speed, and cooldown, which is the frequency at which they shoot. All of this can be adjusted. So the sync between Machinations and Unity is done both ways. If I change a value in here, it's going to change for Axon in the game. If Axon changes a value in Unity, it's going to change back into the model here. You can see that I'm live editing with Axon. He's in the corner here. So either one of us making changes in the diagram is going to reflect back into his game. At the moment, you'll notice that our player damage is 800, while the AI health, which is now 600 because it got buffed 2 times, but it starts at a value of 200. So effectively, whenever the player successfully hits an enemy, it destroys that enemy. That's why the player is very overpowered at the moment, and he's never in any threat of losing the game. The part that we added, which are the buffs and debuffs that Axon mentioned, are treated, and I'm gonna want to show this again separately, are treated through a random gate. As you can see, we have 5 different pools for each bot tank. And those pools are effectively checking if the tanks are still alive or not. And as soon as one tank runs out of HP, which hopefully will happen soon, there we go, AI1 just died. We push one resource forward into the random gate, where it can go in many different places. There's a lot of options here. And all of these options, as you see, have different weights on them. So for projectile speed, we have a weight of 55. Player speed is 55. So those two have an equal chance of occurring. Most of them are at 55, so they have an equal chance. For instance, enemy speed has a chance of 100, so it's almost double the chance of any other buff or debuff to happen. And whenever that resource enters the respective branch, you can see it enters, for instance, damage weight where it entered increasing the AI damage. It will essentially buff the AI damage for that run. The run stops either when all of the 5 tanks are dead, or only the player dies. If the player dies, the execution stops immediately because there's no point in watching a couple of bots fight each other. And also, I'm gonna just quick run for a second to show something here. So if we do quick plays with this model, I'm gonna do 5. You're gonna notice a trend, the player usually wins. Maybe not 100% of the time, but certainly a lot of times. And what I've done here is I've added a small player 1 counter, which simply pushes one resource forward if the player is the one that won the match. And the way you're gonna see that on the chart is we're gonna have this little bar here for each execution in which the player successfully won. If the player didn't win, we will have no such bar, so it's easy to track, easy to see for everyone. So as we see, the player has 5 out of 5 games won, definitely overpowered, definitely strong. So we're gonna be working on that. One final mention I wanna make before handing it back to Axon is that the way we modeled accuracy is by a formula, which we kind of worked on and is still not perfect. Basically, we take into account projectile speed, projectile radius, and the own tank speed to determine the chances of a successful hit. Because obviously, the faster the enemy tanks are, the harder it is for the player to hit them, for instance, or the faster the projectile can fly, the easier it is to snipe from a distance. So factors like that are taken into consideration, where we have a different formula. This is the one for the player, which determines the player accuracy, taking into account all those factors. And for the enemy tanks, we have 2 types of tanks. There are the so-called zombie tanks, which chase and try to shoot the player or the nearest enemy tank. And those are modeled in this register here, where they take certain parameters into account in order to determine their accuracy. We also have one sniper tank, which you might have noticed in Axon's initial presentation, where a tank is just standing still and trying to snipe at the other tanks, but without moving. We did this approach to show that we don't only need to model one single tank. So all those tanks are not just copy paste and you can do 100. You can have different tanks with different behaviors, different intelligence. So for instance, the sniper tank is more affected by the player speed or the enemy tank speed. So if those tanks are, the faster they are, the harder it is for the sniper to hit them because the sniper tank does not move. So that creates a different logic for the sniper tank. In our diagram, AI5 is the sniper tank and the other 4 are the zombie tanks. So this is the model. I'm gonna hand it back to Axon and we're gonna try and balance it so that it's a fair fight between the player and the bots.
Before we get into that, there's a quick question from the chat.
All right.
Is the projectile radius its hitbox or the explosion when it hits?
The explosion when it hits. The radius in which the explosion. You'll see that the explosion has a small AoE around it.
Yes, exactly.
Nice. So Axon, now that Cesar's made this amazing model that's simulating the game, how do you actually go about connecting the Unity engine with the Machinations model?
Yeah, I can show that for sure. So I'm gonna boot up the code editor, and what we do is that I'll start from the tank. So we have this tank in the game, and the tank has some scripts on it. For example, it has a health script that handles its hit point and so on. It has a shooting script, and it has a movement script. And these scripts receive values from scriptable objects. I showed you a bit earlier one of the scriptable objects, for example, the tank stats. You can see its values here. So over in the health script, we we have these scriptable objects defined. This scriptable object is defined here in the health script, and all the game logic around health takes values from that health script. By the way, what I forgot to mention is that at the beginning of the round, all the buffs are reset. So every round we start fresh, resetting all the buffs. Okay, so a scriptable object that is Machinations friendly, so to speak, it has this element base defined here. So it has element base variables, which can be represented in the Unity editor. They have this little blue M here, which means that they are connected to Machinations. What this means is that we have a manifest defined in the scriptable object, and inside the manifest we have this this structure defined, which shows what property goes to what machination element ID. In this case, we have health, speed, health buff, and speed buff. And if you go to the diagram for the player health right here, let's see, player health has element ID 8919. It's this thing with a hash symbol right here. And this is, sure enough, the element ID from the scriptable object. You don't necessarily have to handwrite this. It's not much to write, really. It's quite simple, and it's mostly copy paste. But we have actually created a element importer. So once you get your plugin from the asset store, you open this Machinations control panel. This is where you put your user ID and your diagram token. And this is where you have this import elements button. And by using this, you can actually filter directly on the diagram. You can select what elements you need to import. You select some elements, boom, click generate, go back to your code editor, and there you have it here, generated as a scriptable object, ready for you to basically just drag and drop to one of your assets. It needs a bit of formatting, but it's syntactically correct. I think that's it in a nutshell.
Fantastic.
All right, so Cesar, have you nerfed me?
I haven't done anything yet. So what do you want me to do?
Let's get everybody's opinion.
I'm gonna nerf myself.
Wait. Matthew's asking for their opinion.
So right now, the player is super overpowered. They have loads of health, and they the majority of the time when we ran the simulations, the player was winning, and we can see that when Axon's playing this and paying attention to it rather than talking to us, the player is often winning. So if you were making this game and you could see that the player was overpowered, how would you want to adjust the balance? So we've come up with a couple of options. The first one is increasing the enemy damage. The second one is reducing the enemy cooldown so they fire much faster.
One mention I want to make is we're definitely going to reduce player damage first, so that comes without the saying. This is additionally. This is an additional health that we want to give to the bots. So player damage is going to come down from 800 to 80.
Okay.
Perfect. Zach was ahead of us there. He'd already spotted that and made that suggestion in the chat. Thank you, Zach. So we'll adjust that as well.
I've already adjusted. It should actually be represented in the diagram. Let me switch to the webinar layout so I can show the diagram as well. Okay, let me go for this.
I'm going to end the poll there. Let's have a look at the results. So the number one result is reduce the enemy cooldown so they fire faster.
This is Axon is going to like this.
Yes, I love that stuff. But now that I actually reduced my own damage to 80, let's see the diagram. What does that say? I've hit some quick runs now, just for the sake of it. So what do we have here?
Yeah, you can see that the player is still winning. That's mostly due to the fact that player damage was reduced to 80, but it's still higher than AI damage, which is 50. And the player health, as you can see on Axon screen, is 420, while the AI starts with 200. The reason you're seeing 400 on Axon screen is because they hit a health buff. You can see the pool on the bottom there. They hit a health buff and they added 200 to their HP. But normally bots start with 200. So the player has over double their health. So the player is still a heavy favorite. And you can see Axon proves it through his mechanics. Now, we're going to make the tanks shoot faster. And we're also going to give a slide, because there were a couple of votes there for increasing AI health. We're going to give just a slight adjustment to that as well. I'm going to make AI health from 200. I'm going to set it to 250. And we're going to make the AI shoot twice as fast. So
just move the Machinations model, Axon, so we can see what Cesar's doing to the cooldown.
Yep.
Yeah, so as you can see, the AI cooldown is currently 4, and with the cooldown buff is 2. So whenever we hit that AI cooldown decrease, so they shoot faster, they will shoot 2 seconds faster. So essentially, one thing I forgot to mention is that 1 step in this diagram means 1 second. And that's because of the way that we keep track of player and AI cooldown. Essentially, an AI cooldown of 4 means that the bots will shoot once every 5 seconds. An AI cooldown of 0, I'll let you see what that means. But I'm going to reduce AI cooldown from 4 to 2, so I'm going to make them shoot twice as often.
Actually, we started with 2 and 1 because of the previous tests that we've been making, and then I changed it to 4 and 2. So you can put it to 1 and 1.
I put it 1 and 1 exactly.
1 and 1.
So the AI cooldown now is gonna shoot. AI is gonna shoot more frequently, and they're gonna have a bit more health, so a bit more survivability.
Yeah. And basically, when you have 1 and 1, the first cooldown drop that drops will make them be quite eager to shoot.
We also have another message. I wouldn't increase rate of fire because there's a ceiling to how much we can increase before becoming overwhelming. Instead, increasing damage creates more anticipation for the player without removing agency further. Sure, we can work on AI damage as well, which is probably going to be the next step, since I have the faith that Axon is still going to win.
Yeah, we'll see about that. Okay, got this one.
The point of this webinar is that we all make Axon suffer, so we're obviously going to get to a point where he's sitting there crying, and the next step is probably going to be to increase AI damage.
But actually, my damage right now is it's hard. It's not enough.
So the beauty of this is that we can see all those values very simply in Machinations, and we can hit quick play, see the outcome of them, see what those differences are, hit the quick play button, and immediately start to get those results so that we can make decisions.
Yeah. I'm just going to buff AI damage right now up to 80, and then Axon can hit some quick plays, and we're going to see what that means for our model. And
I was very lucky a bit earlier because they went into the machine gun mode because the cooldown cooldown buff dropped, and I only had the sniper tank left, so that was lucky. But now I'm caught between 3, so that's very, very nasty.
After you are humiliated by the bots, hit a couple of quick plays so we see the difference.
Quick playing.
One thing you're going to notice, the biggest thing we can take, so you see the player is already losing, so they're not winning anymore. Much like Axon is not winning at the moment. But another thing that we can notice is that making the AI have more damage means that the games last for less. So you can see in the play history on the left of the diagram that we have 30 steps, 19, 41, 29, and 38. That's because the AI can shoot each other. So increasing bot damage means increasing everyone's damage on the map except for the player. So that means everyone's going to die faster because they shoot each other, and we're going to have much faster games. This is why it's an important decision to make if you want everyone to have high damage, so you have shorter rounds, or you want everyone to have low damage, so it takes multiple hits before anyone dies, and so you have longer rounds, because longer rounds tend to favor the player.
Perfect. There's a question in the chat, which is there a percentage reduction as well? Seems like the cooldown should be reduced as a percentage, because otherwise you get to zero very, very quickly.
It's not percentage based. Yes, very good question. You can model it to be percentage based. We didn't. We made it flat. Initially, our model starts with the initial parameters that we had. It used to start at 4 and decrease by 2 every time you hit that debuff. Because of how many buffs and debuffs there are, you're usually going to get that debuff maximum 1 time per game. And that's why it was modeled like this. Depending on your approach, of course, you can make it percentage based. So that's your own. It depends on how you build the model or the game. It's your own choice to make, but it is definitely possible.
For us, modeling this as flat values was a bit simpler. So we didn't have like a ton of time to improve the enemy AI and these sort of mechanics. So we went with something that is enough for us to demonstrate.
Perfect. But it's a great suggestion. It can definitely be done, Zach. It's a really good approach. One of the things, actually, while we're on that subject and you were talking about the drop rates, Cesar, how have you modeled the different drop rates? Do you want to just talk through the gate?
Yeah, sure. We can.
Detail.
I can stop sharing and you can share this one.
Yeah, sure.
I think they've had enough of watching me lose. Actually, I can confirm that it is quite a bit harder than it was like the second game. Okay, the beginning was definitely very easy. The second part was manageable, but now it's a bit of torture. Not still doable, but
yeah, you can see the values that we have here. I've brought the player damage down to be the same as the AI damage, and we've also buffed the AI health a bit, and they're shooting at the same rate as the player. So they're kind of on equal grounds, but it's a bit of a 5 versus 1. So Axon is struggling a bit. Now, what Matthew was talking about is what I presented in the beginning with the random gate. As I said, the weights of those buffs and debuffs act as their chances to be triggered once one of those tanks died. That's why the connections are the nodes from which we pull our variables into Unity, or which we transfer from Unity into Machinations. And those weights essentially act as percentages. So if I were to slap a percentage in here, just make it 55% instead of 55, it would be the same deal from a Machinations perspective. But because of the way that Axon modeled it in Unity, there has to be a synchronization between Machinations and Unity. So I can just make percentages on the diagram if the game uses weights as integer numbers. That's why we should adjust them both ways. So essentially what happens, as I said, is when one resource is pushed forward, it will choose the outcome based on the weights, of course, in a random manner. It's not a deterministic manner. This is actually the main selling point of Machinations, so to speak, the Monte Carlo simulations, where no execution is going to be like the previous one. And based on those weights, if I were, for instance, to go to AI cooldown weight and make it 1000, let's say, that's obviously going to mean that there's a much, much higher chance for us to trigger the AI cooldown debuff, so to make the enemy tanks shoot faster. Obviously, they are capped at 0, so they can't shoot negative values. They're not going to shoot faster than light or anything, but we're going to trigger that debuff most of the times. One other mention that I want to make here, it's pretty, from a game design perspective, you'll see, for instance, on tank speed that we have an extra register in here. Now, that's because we have 2 certain debuffs that affect the game quite a lot, which one is the player HP debuff, which means that when that triggers, the scissors, when they trigger, the player instantly loses 100 HP. And we have to take into consideration what happens if the player has under 100 HP when that buff occurs. Does it instantly kill the player? The answer we came up with was no. If the player is below 100 HP, they just ignore that debuff. That's why we have to make a little check here to see, okay, what's the player's current HP? And if it's below 100, just ignore the debuff. And same with speed, where we didn't want to reduce it all the way to 0, so thus making the player stand still, because that would be just an unfair disadvantage. We capped it at 2, so it cannot go below 2. In the case where you have, let's say, 5 speed and the debuff is 10, for instance, it would just drop you to the minimum value, which is 2. We didn't do that, for instance, for projectile speed, and maybe we should have, but it proves a point. So projectile speed can go to 0 actually, and that means that you just shoot, no distance at all. You're effectively hurting yourself because friendly fire is possible, and that gives the player an impossible chance to win the game. There's no way they can win in that case.
Not really. You can shoot the projectile and then move away from it very fast, and before it drops, it explodes. I've done that in the past, but
it makes it way harder. Let's not say impossible, because I should have mentioned this in the beginning. Axon has been playing the game a lot in preparation, so he's really good at it. So it's important to put those limitations.
Sorry, I have a couple of questions when you're ready, Cesar.
Yeah, go ahead.
Okay. Is this limited to only synchronizing a data store, or can it pull in actual behaviors from the Machinations API? So
that's for Axon, I hope.
Yeah, it's I would say that right now it's just sending the values, just data. It's a data-driven approach at this point.
Perfect. Now this is a slightly more lengthy question. Some values matter at different points in a life cycle, etc. Build time versus runtime. Is there a way to control this in the integrated script assets? Also, for the polling or push-pull of the data from the API at runtime, how frequently does it do this, and what are the API rate limits? Can you control how frequently it updates to reduce the usage of the API where it makes sense to do so?
Okay, I'll start with the end. The frequency of the API is already optimized quite well on the plugin level, so it only does requests when they are needed, because we're using socket.io. And because we're using socket.io, it's just direct communication, so nothing is wasted, and we don't like poll unnecessary. Regarding to control this in the integrated script assets, so yeah, of course, everything is actually integrated. It's controlled through scripts that are the plugin itself. So everything that the plugin does is, the plugin is actually open source, so you can go in the script and change how all this is done. And actually, I realized something about the earlier question, since we're talking about scripts. So we can transfer from Machinations the labels on different connections, so conditionals. That's what I mean by this is behaviors, right? So conditions and behaviors and registers can be transferred to Unity. The problem becomes how do you map these kind of generic behaviors to your game? So for example, if you have, let's say, a condition that says that the player should enter a certain area only if this is greater than 5, if he has 5 coins or something. This can be transferred to Unity, but it's your responsibility to interpret the condition. Like greater than 5, it should mean coins, and you have to do a little bit of tinkering yourself. But we allow some form of that, and we are very open to use cases in which we can do more. Okay, and back to the question, Justin's question. I'm almost reading it.
I think
okay, so how frequently does it? That was the only thing that I didn't cover. So it actually has an init request when the game starts. So always that happens, the init request, and after that it only does it as I said earlier. So yeah, I think I covered everything.
Perfect. Great, thank you. So I'll let you, let's get to balancing this model.
Okay, I'll keep sharing again, and maybe it's time for another poll.
Yep, absolutely. So obviously, you can interpret how you like in terms of how you would want to balance this game and what you think we could do to improve its balance even further. So I'm going to chuck a poll up. How should we adjust the balance? We can either reduce the player health, increase the enemy health, reduce the player damage, or increase the enemy damage, all to make it even tougher. There's no right or wrong answer.
I would say that even tougher is going to be very tough. You were touching, Matthew, on that thing with the machinations model being a good representation of a generic situation, how useful that is. Because now, yeah, I'm skilled indeed, because I've been practicing a lot with this game. I'm not super skilled, but in any case, it's also very true that all your players eventually get skilled. They become skilled. So eventually you will get somebody that can play very well.
It's true. It's always about finding the balance, though, because we don't want a brand new player into the game to have a horrible experience and it'd be far too tough. I'll end the poll and let's share the results. Everyone's saying increase the enemy health. Not everyone, but the majority.
I like that remark with everyone said that. Okay, just because the majority was there. Yeah, so people want longer games. So we're gonna give them longer games. Axon, if you would be so kind as to move to the left side of the diagram where we have the health for the player and the AI, so they can see what's happening, and also reset your model if you can, because your model now has the values from the last execution.
Yeah, I've done that.
Can you do it again, please?
You mean clear the chart?
No, reset.
Reset down the bottom.
The model.
Okay, the reset. Sorry, I accidentally hit refresh. Anyway, same stuff. Same stuff.
Okay, same result, different method. So we're gonna increase AI health from 250. We're gonna give it the exact amount that the player has. So I'm gonna make it 420.
Yeah, 4,200.
Yeah. That was a bit eccentric. And I'm also gonna reduce the player damage for a bit. So you can see it's 80 on the right. Now I'm gonna make it 70 for both. And I'm seeing a message: reducing player movement speed would be interesting too, since they are much faster than bots. Why not? We have a player tank speed of 20. Why the heck? Let's make it 10. Let's see what happens.
Look at my screen. Oh no! You nerfed me!
Perfect.
Okay.
So hit some quick runs if you can,
Okay.
Axon, and let's have a look at see what the model's saying. If it's a winnable game now.
Yeah, the
It was the first time. It was the first time, and the second time it wasn't. Okay, there's a bit of a struggle going on there. Okay, so the games are fairly. So as opposed to before, they are still fairly short. It takes 6 hits, because the health is 420 and the damage is 70. It takes 6 hits for a tank to kill each other. So I'm thinking of nerfing the damage even more. Let's bring it down to 50 for both. The games are fairly short. You saw, or if you didn't, I'm gonna tell you because I can interpret the charts quite easily. The player only won the first game, so it's a 1 out of 5 situation.
I actually did one just the round before I managed to win it, because I kind of had a pretty lucky position, and that happens. I mean, you get into lucky positions.
Yeah, but now
when they kill each other.
You're getting kind of smoked now.
Yeah, because now I spawned next to 2 chasing tanks, and they got this cooldown stuff going on, and they're like, so now I have to cheat. I can't even cheat my way out. I was trying to run away, but because of the speed debuff, I can't do it.
Excellent. So our model's accurately representing what's going on in the game. Good.
I can tell you that for me and Cesar, this was always a very fun experience to do this kind of balancing, and this even doing it in this webinar and suffering a bit because I'm losing. It's still, for the game designer in me, because I'm also a game designer, it feels like it's really cool to do this with another fellow game designer, one in the game, one in the diagram, changing stuff.
Yeah, it's really nice.
Okay. This guy is coming angry. And I have this shell cooldown debuff, which means that I cannot shoot as frequently. Okay, so a set of 10 matches.
This is another thing I wanted to mention. The game plays for 10 consecutive rounds, and after the 10th round counts whichever one has the most victories, and that's the final winner. We didn't have that implemented in the diagram. We can do it. Again, it's up to everyone, because we will be sharing the model with you at the end of the presentation. We will be sharing both Axon's game and my Machinations model, so you can tweak it however you want and see the results.
Yeah, this is in GitHub. The only thing you need to do is to update the user key and diagram token, so you can enjoy the massacre.
Have you shown them where they can get them?
This is the same link from the quick start tutorial for the up plugin. So we have our quick start tutorial. Is that?
Do you want to show us where it is though? While you
the diagram token, I mean, where you get it from.
Ah, the diagram token. All right. Okay. You just click the diagram title and you have it right here. Copy token, and then it's done. And also you have to go to your user settings to copy your user token. And then you put them in the game, well, in Unity, you put them here in the Machinations control panel.
Sometimes it seems like the explosion is really far from where the enemy tank is, but they still get hit. Well, we have a radius of 10. I guess we can drop it down to 5.
Yeah, but maybe, hold on. Maybe the buff for explosion radius dropped.
Yeah, Axon is right, because the initial value that we have for radius is 10. Okay, the initial value that we have is 10, and the buff, the radius applies to both player and enemy. So there's no distinction here, and it increases it by 20. So it effectively triples the radius. That's why it's quite noticeable when it drops.
Yeah, no, actually, I think it was something else. I think it was the explosion force. I was looking at the buffs and debuffs here in the list, and I think it was force that was causing that. Because if the explosion force is increased by 600, because it's quite a lot, then everything starts flying around.
Yeah, again, the projectile force starts at 100, but the buff gives both the player and the AI extra 600. So it's quite a bump in force. Everything's flying around. If any of you try and do what me and Axon are doing here later, just set the radius to 1000 if you want to have fun. You're gonna see it's gonna be nice.
One shot, no matter what, kills everyone.
Well, not necessarily.
1 second rounds.
If the damage is small, I think it's more like, let me put it actually to 1000, the radius for the enemy, and for the force, let's
You can
say.
see that all the structures are dropping.
Boom, look at the pinball now.
Yeah, so as you can see, there's a lot you can model here. So
okay, changing back to normal. Okay, that was fun.
Perfect. Please do, if you have any questions, please do drop them into the chat. Have we covered everything we were planning to cover, Cesar?
Why are you asking me? I think so. I've covered everything I wanted to cover. I don't know about you guys.
For me, I would say that right now the game is a bit too hard. So I would like to cover the fact that I think my damage is underpowered compared to how many enemies I have to kill.
Fair enough.
I mean, every shot counts, and at least the shot that the player gets, they should be rewarded. So I boosted myself to 100 now.
Except you boosted the AI to 100, but that's fine. You can.
Oh, right. Oh, okay. Good spot. Yeah. Okay. Good spot. But actually, let's leave it like that. Let's leave the AI to 100, and my own I'm gonna put to 150.
And while Axon tortures himself, if anyone has any questions for us, if for the game, for the model, for anything, the integration.
Perfect. So the key to all of this is just being able to speed up those workflows and reduce the time it takes to do that round trip of wanting to test something out in terms of a game's balance or even a game's progression. We've been focusing this session just looking at kind of the tank game and how we would adjust the balance to make it a fun, well-balanced player experience. Obviously, this could be an entire progression system. It could be a rewards platform or even a gacha box mechanic. And we can just use this to really quickly understand what the impact of a small change is going to be across the entire player journey. So even things like, well, what's the impact on the player speed? It's going to take Axon 5-6 minutes or so to go through and play that and get a feel for it. Whereas in Machinations, we can make that adjustment, hit play or quick play in the model, and we can see the impact of those changes really quickly. So the whole idea of this is just cutting down that round trip time of wanting to understand what the impact across the entire player journey is going to be from what could be a small change, but it could have a dramatic effect over a large period of time.
Before we go to the Q&A, I want to mention the fact that the hardest point in this balancing process for me and Axon was were the accuracy formulas, which we couldn't get down. And the process for that accuracy formula was actually really cool, because I was talking to Axon and saying, okay, I don't know how strong everything, every factor in the game influences the accuracy, because obviously some stats are more important than others, like speed should be a big factor because being fast means dodging easier. And he was playing the game and giving me back data, like, okay, I noticed that the speed is kind of influences that much, the projectile speed. I'm having a hard time if I'm not shooting far and stuff like that. And in return, I was simulating in Machinations with the new data and saying, okay, by the looks of it, you should probably be winning like 40% of the time or whatever. And he was, okay, I'm actually at around 60%, so let's adjust that a bit more, give the weights a bit more, adjust them a bit. And it was a really, really cool process.
Yeah, and that can happen either on the fly directly when we do it, or like when we both are working on it, or you can make you make a change and I see it later. But what I also agree with is that even though the formula is not necessarily connected to actual game data, the important thing here is that you get something going. You get something that feels right at sort of all levels. So of course, because there is high randomization, which is actually something that I love about the current mechanics, is that we have 10 different drops, buffs and debuffs, and this creates a lot of diversity. And the fact that we actually managed to nail the diagram so well to the game is very encouraging. And for me, I mean, I'm very happy when I see that this is doable, this is possible.
Matthew, mind reading the Q&A with your
certainly.
Sports commentator voice? Okay.
Sports commentator, wow. Is there a world in the future where we can either use Machinations APIs to process the game state, or else export Machinations as something we can host ourselves or run locally on clients instead of needing to implement our own game state processor? So, Axon, if you want to cover that one, or if you want me to.
Yeah, you can start, because I was playing and I couldn't focus on the full question. I'm reading.
It's actually the sort of use case that we've thought about, and it's one of those items on our product roadmap that we've thought about, and we would love more input from users on whether or not it's something that would really add benefit for you. So if you'd be interested, we'd love to explore that a little bit more with you, and look at how we could what would actually make sense and what would you like to do. One of the challenges is that obviously with Machinations, there's one copy of the model per game, if you like. So you can take all those kind of settings and you can apply it to the game. If you wanted to track kind of each player's progression and almost have one copy of the model per player, it's something we've thought about, but we haven't got to that point yet. So we'd love to talk to you more about what sort of features or how you would hope that would work, to see if we can build that into our production roadmap.
And I also can add something here. So we've been thinking a lot about machine learning and about how we can speed up certain things by getting data from the game. And also to be able to run certain scripts locally, like for example, to determine this thing with player accuracy. We've been thinking, okay, what if the game reports an average accuracy for every gameplay? And then we can use that to determine if the accuracy in the model is better. And also when it comes to game state, the Unity plugin supports game state, something that is called game state awareness. Well, it's architected to support it, but we haven't fully implemented it, mostly because there wasn't much use case for it. So there weren't many people that actually needed to be aware of, to process game state and to be aware of of whatever changes happen at the game logic level. And again, as Matthew said, we're quite interested to see and to hear about how would you think this would work, and what would you like to happen in that regard. Perfect.
Thank you. Please do let us know if you have any questions. Please do drop them into the chat or into the Q&A. What's going to happen next is we're going to send you out all of this content so you can have a play about with it yourself. As we mentioned, you're going to receive the GitHub link to download the Unity project, and also a link to the Machinations model, so you can have a play about with it and see how you'd balance this and see how Cesar's constructed this model. At the end of today's session, when you leave the webinar, you'll be taken directly to a page where you can actually book some time with us and come and talk to us about these sorts of challenges. And we'd love to get some of your input on how you'd like to see the Machinations API work in the future.
Matthew, I think it's good to mention that the API is a premium feature.
I was going to, but thanks for the seamless segue, Axon. So yeah, Machinations, the API plugin, is a premium feature. So you will need either an indie account or a studio or AAA account in order to have access to the API features. If you want to have a trial, please do hit the button at the end of today's session, book some time with me, and we can talk through getting you set up on a Machinations plan. Great.
And just what we have in GitHub, the project that we have in GitHub has the Unity plugin already integrated, so you don't need to download it from the asset store. It's fully functional and packed and ready. But if you want to integrate in your own production, then you need to get it from the asset store.
Perfect. And we'll make sure that there's a link into there. I'm going to ask Horia to drop in all the links to the our social channels. Please do come and hang out with us in Discord and Slack, and to see all of our content that we've done in previous webinars and a whole load of other useful instructional videos on how to use Machinations, please do check out our YouTube channel.